So welcome to PA Academy. So in this video, we're going to be looking at this example under electric field intensity. So this example is going to cover for the other two videos. I already explained what electric field intensity is all about. All right, so now let's look at it. It says, given four identical charges located at point P1. So P1, they gave the coordinate of P1 for this P2, P3, and P4 as shown. Find the electric field intensity E at point P. So now this question is quite self-explanatory if you really understand how to go about it, in such that apart from giving the question, they also gave a diagram illustrating what the question is asking. So you are asked to find the electric field intensity at point P. Now this is point P. So this right here is, so this point here is the point P that we should find the electric field intensity at point P. Now you can see that the other charges, the P1, so this is P1, P2, P3, and P4, they are already given. So what is the electric field intensity acting at point P due to the charges of P1, P2, P3, and P4? So that's what we are going to be looking at in this example. All right, so let's get started. So remember in the previous part where I said if you had to look for the electric field intensity between 2 points charge, where we have E is just, that means we are going to look for the electric field intensity due to each individual charges. Exactly. So each of these charges, we are going to look for the electric field intensity and sum them up. So with that, we are going to get the electric field intensity at point P. So what I'm saying is we are going to calculate the electric field intensity of P1 on P, or that of the electric field intensity of P2 on point P, that of P3 on point P, P4 on point P, then we add them up together. So to do that, let's first of all write out the electric field intensity itself. So that is E is equals to Q over 4 pi E naught. Then the magnitude, so let's just represent that with R. The magnitude of the unit vector, the square of it, then multiply by the unit vector over its magnitude. So that is R. So now let's just represent it like that. So that means we are going to look for this value for each of the charges, exactly. But however, since the question says that four identical charges, so the question says the charges, that means P1, P2, P3, and P4, they both have, they all have the same charges of 3 nanocoulombs, exactly. So that's 3 times 10 raised to the power minus 9. So that makes work much more easier for us. Now let's do this. So one of the things, first thing that we also need to get is the unit vector and its magnitude for each of these charges. That is for that of P1, P2, P3, and P4. We are going to calculate their unit charge. So now for us to do that, so let's start with that of P1. So let's calculate the unit vector of P1 on P. So for us to do that, let's call that R1. So this P that is at the center, let's call it P naught. So let's just represent its magnitude with R naught 1. So that will be. Now, another thing you just need to also notice, just the same way we are looking at superposition of Coulomb's law. So we are going to subtract all the charges from P naught, which is the one that they are all acting on, for us to get the unit vector of each of them. So for that of R naught now, so that will be, we already know that P naught, the magnitude, the coordinates, this is for X, Y, and Z. So this is for X, Y, and Z. So the same thing applies to everything. So for this now, we are going to be having 1 minus 1 AX plus, so that means 1 minus 1, that's for AX, then also 1 minus 1, and here is going to be 1 minus 0. I hope you got what I'm doing there. Okay, plus 1 minus 0 AY plus, okay, so that is 1 minus 1, not 1 minus 0. So this is 1 minus 1, then this is 1 minus 0 AZ. So if you should put this together, we are going to be having, this is going to be giving us 0, so we can just cancel this. this is also, so this is also going to give us 0, and here you are going to be having 1. So that means you're having 1 AZ. Okay. So since we've already gotten the unit vector, let's go ahead and get the magnitude ones. So for us to get the magnitude, so that will be the magnitude of R O naught. That will just be the square root of 1 square, and then 1 square is just 1. So you're having the square root of 1, and that will also give us 1. Alright, so let's calculate for that of RO2. So I've gone ahead to write out the coordinates for P2, P3, P4, so that you can just make reference to easily as we proceed. Okay, so for this now, we are going to be having 1 minus, so for 2 now, this is it, 1 minus 1 AX plus 1 minus, so for Y, minus 1 AY plus 1 minus 0 AZ. So if you should do this, we are going to get, this is 1 minus 1, that's 2AX, so 2AX, so don't forget to put the bar at the top, plus, so 1 minus 1, this is 0, this is out, then 1 minus 0, that will be 1, so we can just write it as plus AZ. So now let's go ahead and calculate its magnitude. So that will be R01 is equals to square root of 2 square plus 1 square. So if you do that, that's going to give us, this 2 square is 4 plus 1, that's 5. So we are going to be having the square root of 5 as the, so that's root 5. So just this double dash and put, I'm just trying to separate it, so it's not actually any big deal though. So don't mix it up. So now let's do for that of, so let's calculate for the unit vector. So for R03, R03, okay, for R03 too, that will be 1 minus, so for 3 this is it, minus 1 AX plus 1 minus 1 AY plus 1 minus 0 AZ. So this will be 1 minus 1, so that will give us 2. So we're having 2AX, and this is 1 minus 1, so that will be plus 2AY, and then 1 minus 0, that is 1, then plus AZ. Okay, so that's the unit vector. So let's go ahead and calculate the magnitude. So RO3, so this should be RO2. Okay, so this will be 2 raised to power 2 plus 2 raised to power 2 plus 1 raised to power 2, and that will give us square root of 9, and that's 3. Okay, so I hope you can still see that. All right, so now let's do for the last one, which is R04. So for R04, so all of this calculation I'm doing is actually part of the solution, so don't think that you can just decide to skip it and go straight to your answer. So for R04, so this is 1 minus 1 and 0. So this will be 1 minus 1 AX plus 1 minus 1 AY plus 1 minus 0 AZ. Okay, all right, so 1 minus 1, this is out, then 1 minus 1, that is 2 AY, then 1 minus 0, that will be plus 1 AZ. All right, so now let's let's calculate for its magnitude. So that will be r naught for the magnitude. So that will be square root of 2 square plus 1 square. So that will be 2 square plus 1 square, and that will just give us square root of 5. Alright, so with what we've been able to do so far, if you watch the video when we are calculating the force acting on multiple different forces acting at the point, you see that there's a similarity between it and that of electric field intensity. But the difference there is that for this now we are only having one charge, which is Q, unlike the other one where we are having Q1 and Q2. So that's just by the way. So now let's continue with this. Now that we've gotten the unit vector for all of those charges and their magnitude, so now let's bring in our formula now. So the electric field intensity. So remember that we are dealing with electric field intensity due to four charge, and the charges are equal. So we can just write 4 identical charges. So we can just represent it as Q since they are all the same charge. So we are going to be having Q over 4 pi E naught, and then for RO1, so that will be RO1 square multiplied by the unit vector RO1 over its magnitude. That will be RO1. Then plus, so this, let me just put it in square brackets, plus Q over 4 pi E naught, then RO2 all square, that's the magnitude, multiplied by RO2 over RO2, which is the magnitude. So this is for the second charge, which is P2. So then plus Q over, so just follow along. I want to explain something here. You would notice that there is a pattern in what we are writing. So for RO3 square multiplied by RO3 over its magnitude, and then so this space will not be enough, let me write it here, plus Q over 4 pi E naught RO4 square multiplied by RO4 over its magnitude of RO4. Now if you look closely at what we are having here, you see that this is common with all the 4. We have this, and then this. They are common because, like the question said, all the charges, that is the Q, this Q1, Q2, Q3, and this Q4, they are all the same value, 3 nanocoulombs. So with that, we can easily factor it out to make our work much more easier. So that means our E will be equals to Q over 4 pi E naught, all into brackets. So for this now, we are going to be having RO1 over the magnitude of RO1 square multiplied by RO1. So this is for the first one. So let's close this. Now at this point, you might be wondering that why not have it as since they are RO1 and cube, but let's just leave it, let's separate it like this. So then plus, so let's come over here. So for this now, we are going to be having, let me open my square bracket. So RO2, which is the unit vector, over, so its magnitude all square multiplied by its magnitude again. Then plus RO3 over its magnitude of RO3 all square, and then RO3. So this is it. Then for the last one, so that will be RO4 over its magnitude of RO4 square multiplied by RO4 its magnitude. Then we close our square brackets. So at this point now, before we put in the value, let's try to calculate this. So if we have Q, remember our Q is 3 nanocoulombs, so that is 3. So let's try to find the value of Q over 4 pi E naught. So that means our Q is 3 nanocoulombs, which is 3 times 10 raised to power minus 9 over 4 4 pi times 8.854. Remember, that's a standard, times 10 raised to the power minus 12. Okay, so if you type this into your calculator, let me do that and see what I'll get. So if in the previous video I've explained how to calculate values like this easily using your calculator, so let me do that here. So if you type that correctly, you'll be having 26.963. So let's just keep it to 2 decimal place. So that'll be 26.963. So let's just keep it to 2 decimal. So that'll be 26.96. Then vote. Exactly. So now that we know the value of V, so that'll be our E. It will be equals to 26.96. So let's open our square bracket. So our RO1, so that let's start with this. Our RO1 is 1 AZ. So we are having 1 AZ over, so the magnitude of RO1, we got that to be 1. So that will be over 1 square multiplied by 1. So plus, so now for RO2, so that's the unit vector RO2, we've gotten it to be 2AX plus AZ. 2AX plus AZ over, so the magnitude of RO2. Okay, so that's root 5. So root 5 square, let me just write it out. Root 5 square multiplied by root 5. So let's move to the third one. So for RO3, it's unit vector, this is it, 2x plus 2ay. So don't forget the bar at the top, 2x plus 2ay plus az, plus 2x plus 2ay plus az. Then its magnitude is 3. So over 3 square times 3. Then plus, so for RO4, its unit vector is 2ay plus 1az. 2ay plus 1az over, so its magnitude is root 5. So that means we are having root 5 square times root 5. So we can close it. Alright, so now let's simplify this further. So that means our E, which is 26.96. So if we should simplify this, we are going to be having AZ, because this is 1 divided by 1, then plus, so this will be 2AX plus AZ over, so square root of 5 square is 5, multiplied by 5, so we are having 5 root 5 plus 2AX plus 2AY plus AZ, so don't forget the bar at the top, over 27 plus, so for this now, 2AY plus 1AZ, let's just leave it at AZ, over, so square root of 5 square, this square will cancel, so we are left with 5 multiplied by root 5, so we are having 5 root 5. So we can close it. So if you are finding value in this, please give the video a thumbs up. If you are finding value in this, give it a thumbs up, and also subscribe if you are yet to. Alright, thank you. So the next thing we want to do is to break everything apart, such that if you look at what we are having here, this denominator, this 5 root 5, it belongs to everything at the numerator, and at the numerator we are having AX and AZ. You can see they are different, they are on different coordinates. Exactly. So the same thing is happening here. We are having 27. This 27 belongs to everything here. So we are going to break everything apart and split it accordingly. So in doing that, we are going to be having our E. So I'm just making sure I don't skip any step. Is equals to AZ plus, so let's split it. Plus 2AX over 5 root 5 plus AZ over 5 root 5. So then we'll go to the next one, plus 2ax over 27 plus 2ay over 27 plus az over 27. Then the next one, that will be 2ay over 5 root 5 plus az over 5 root 5. So let's confirm. So this is 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's just another way you can use to confirm that you actually picked all the necessary values. All right, so let's go to the next line. So the next thing we have to do is, now let's look at it closely. So the one having ax, ay, az, let's bring them together. So our e will be 26.96. So let's open the bracket. So let's start with the one having ax. So the ones having ax, let's see. So this is ax. This is having ax. And then I think that's just it. That's the only two. So we can put them together. So it'll be 2 over 2 root 5 plus 2 over 27 ax plus, so let's look at ay. So for those that are on ay, so let me just give it a square. So this is ay, this is another ay. I think those two. So that means we can write it as 2 over 27 plus 2 over 5 root 5. Put it in bracket and we have the ay outside. Because by the time we open these brackets, we are going to be having this. Exactly. So then, so for az, so that means the remaining ones are for az. So we are going to be having 1, which is for this one here, plus 1 over 27, which is for this, plus 1 over 5 root 5, which is for this, 1 over 5 root 5 plus this, 1 over 5 root 5, all into bracket az. So let me bring back the square brackets. All right. So next, our e, 26.96. So now let's calculate each of these things we are having in brackets. So I'll open my calculator now and calculate 2 over 2 root 5 plus 2 over 27. So that will be 2 over 2 root 5. So that will be 2 root 5 plus 2 over 27. So that's giving us 0.521. Okay, so this is 2 over 5 root 5, not 2 root 2. So that was 5. Okay, so that will give us 0.252. So 0.252. So this is 5 here, not 2. Then ax. So now let's do for the second one, 2 over 27 plus 2 over 5 root 5. So that should give us the same value, because what we are having here is the same thing here. So that will be plus 0.252 ay, then plus, so if we should do the same thing for what we are having here, so let's quickly do that. So that's 1 plus 1 over 5 root 5, so 5 root 5, then plus 1 over 27, then plus 1 over 5 root 5. Okay, so that's giving us 1.215. So 1.215 AZ. Okay, all right. So with what we have there now, we can use 26.96 to multiply what we are having in the bracket. So that means our E will be equals to, so let me quickly type this here, 26.96 times 0.252. So we'll be having 6.79793 AX plus, so 26.96 multiplied by, okay, to be also be the same value here, plus 6.793 AY, then plus, so let's multiply 26.96 with 1.215 times 1.215, and that would be 32.756 AZ. And then don't forget the units V over M, or you can use Newton per coulombs. And what we are having here is the answer to the question. So this is going to be the charge that will be acting on point P due to the 4 other charges at P1, P2, P3, and P4. So I hope you find value in this. If you do, please give it a thumbs up. And if you have any question or doubt, no hesitate to let me know. So if the video is not clear, I will encourage you to watch it once, watch it the second time again, and I believe you really grab it in case you didn't get it the first time. So that's it on electric field intensity, and I'll see you all in the next one.